Okay, welcome. Today we're going to do a demonstration on a DCM rotary grinder. This is similar to a Blanchard, but it is different. This is a model IG 180 SD. Here you have the control. Here you have some of the operator's controls. Here we have the grinding area, the grinding compartment where the chuck is and the wheel is. This is your wheel dresser, similar to on a Blanchard. This axis is referred to as the Z-axis. It's the only axis that's being controlled. The chuck is rotating also, but it does not move in and out as a Blanchard does. This is stationary. What this machine can also do here, if you could see, there's a mechanism that you can tilt the wheel, and that's used in certain grinding applications. So that's what makes this machine or this model different. So I've got the safety switch jump so that we can leave the door open. And I have this in manual right now, so we can move our wheel down to our workpiece, and we have different amounts of feed that we can put in, very fine or very slow to very fast, just for the setting up. Then also in manual, you'd want to turn your spindle on manually and turn on your magnetic table. And of course, like this, if you wanted to, you could actually grind a couple of parts by hand without even bothering to make any kind of a program, which is nice. But you do have a program here on this machine. When we go into the automatic mode, you have actually 3 different grinding cycles that you can program to grind one lot of parts or one actual job with a first grind, a second grind, and even a third grind. I'm not exactly sure why you would want to have that many, but each grind, if we just use the one grind, which I'm going to show you today, has a rough and a finish section to it. So in the rough has a slower spindle speed for hogging off material, and the finish has a faster spindle speed for a better finish. You can set that to any value that you wish. There's also a table speed, and you can adjust that value to whatever value you wish. And you have a feed rate. Now, the feed rate is a little rougher or faster in the rough grinding, and it's a little slower in the finish. You also have a distance, a stop distance. That's the point where the wheel will come down and stop above your workpiece so that you don't hit it. You program that, and then you give it the total amount that you want it to travel from that point on. I have all basically rounded off numbers here for ease of programming and for the video. At a point where your changeover is from your rough feed to your finished feed is programmed, and then your dwell time is programmed. So I have all that in there right now, so I'm going to go over to the auto mode, and I'm going to hit my cycle start. And this will back up. You heard the motor switch into a slower speed. And it's waiting now for me. It had to home itself out. Okay, now we're going to start. And, okay, forgot to put it in auto. These switches have to be put down into auto. Okay, so we'll start again. You see the chuck is off, the wheel is actually off, but it's still coasting. Now the wheel started and the chuck started. And now we're feeding. We're in our rough. You see the rough column is highlighted in red or orange. The spindle is going at what I have programmed here, 1200 RPMs. When we get 5 thousandths from the final size, we switch to the finish feed. Our RPM increased to 1800. I could also change the speed of the chuck if I chose to, but I don't at this point. And now we're in our dwell, our 5-second dwell. It's counting down. And the wheel will retract back up, the chuck will shut off, and the spindle will shut off. So that's the whole cycle. I'll show it to you one more time the right way. You load your new parts, you make size adjustments, whatever. Hit the cycle start button. Spindle starts up. Wheel moves into position. Workpiece starts moving. And we start feeding with our rough feed until we get to what I've programmed for the changeover point, which is 5 thousandths before final size. We'll switch to the finish, which will increase the RPM of the spindle. There we go. Goes down to the final size is 20 thousandths, or stock removal of 20 thousandths. It's actually programmed incrementally in steps. And then back up. And it shuts off. And I guess that's covered everything. You got a